This is question 3, paper 1-1 from the June 2020 exams from Cambridge International. In the description below this video, you'll find a link to an image of this question if you'd like to try it before looking at my solutions. This is going to be a really short video to answer these, and also I must warn you, I don't think I'm the best at explaining these types of questions. So if you know someone better, if you can point me in some direction of a way for me to learn how to teach them better, I'd much appreciate it. But here's how I would do it. The question asks you to take this equation. They tell you so A, B, and C, they basically ask you 3 questions the same. They tell you this guy is fx. This equation is fx. When I put x in, I know what I'll get out. If I put 1 in, I'll get 2 out. If I put 2 in, I'll get 1 out. And if I put 3 in, I'll get 3 out. And that's the only place it's defined. So they want us to explain this drawing using fx. So they want, when I put -1 in, I'll get 2 out. -2 goes in, I want 1 out. And -3 goes in, I want 3 out. Now the answer is, I can write it just straight away, y is equal to f minus x, this should be, minus x. So let's have a closer look at that. We know what fx does. We know what the function, here it is here, fx does. When I put 1 in, I get 2 out. So what we're looking for is something that gets 2 out. Well, when I put -1 in, so if I just go minus -1, well, that's putting 1 in, and I know I get 2 out. So I know this will work for this point. I check if it'll work for the other points. If I put -2 in, -2 is like putting 2 in. I get 1 out, the same thing. If I put -3 in, -3 is 3, put 3 in, I get 3 out. Same thing. So this, that's more me explaining why this works rather than how I got this. I guess I looked at this and I said, this is the same image flipped here. The only thing that's different is the x's are different. All the this x seems to have moved this amount. This has moved a bigger amount. This has moved. So something needs to change with the x only. And what they've done is they've inverted. They've mirrored through this line. And I just know that's a -x. Hopefully that's has at least started you on the journey to how this question's done. Now, if we look at part B, let's think of this in a similar fashion as this. I said here x is all changed. This is symmetrical just through the y-axis. All the x's needed something done to it. In this case, the x's are actually all staying the same. Here, the y's all stayed the same. So if all the y's are moving, something must have been done to the y's. Or to phrase that differently, something's done to the x. For this one, it will look like this. Y is equal to fx. Something will happen to the y. Maybe I'll add a number on. Maybe I add 2 on to everywhere. 2 on here. No, so that's not going to work. 3 on here. Right, so something needs to be done. And it's probably going to be multiplied. That's why we're getting this stretch. This stretch-like pattern emerging. So let's see, 2 is becoming 4, 1 is becoming 2, and 3 is becoming 6. Can you see the pattern? Everything is being multiplied by 2. So this is the answer here. That's what this new function will look like. Y is equal to 2fx. All the y's. Think of fx as y and x as x. Right, let's move on to the last one. On C, it's much more complicated. You're going to get more marks for this one than the others. What is happening here? We have this pattern, and it's not too clear on my drawing, but on theirs is a bit better. This looks identical. It looks like it's just all been moved down here. So that means everything in the x has been moved and everything in the y has been moved. So the answer is just going to look like this. Y is equal to, well, let me write in f first, and there will be an x in there. So let's see what's happened here. The x has all just been moved to the left. So if I move this guy all over to, let's see, we'll put him over here. Just a few lines to help me out here, I'm afraid. Here, here, and here. I should have used a different drawing. I can get him from here to here just by taking 4 away from all the x's. Or should I say adding 4, to get from here to here, I add 4 on. I get very confused by this, so I don't blame you to get confused by my explanation of it. I just double check my answer is what I do. So I want, when I put -1 in, to get +3. So -1 goes here, -1 plus 4 is 3. This is the only one that I understand. F only understands these 3 numbers. So you better get 1, 2 or 3 inside here. 1, 2 or 3 has to be inside here. Same with over here. When I put -1 in, it became a 1. 1, 2 or 3 has to be in here because that's the only place they defined it. So it's x plus 4 will actually make it move from here to here. That's not quite what I wanted. I also wanted it to move from here down to here. So to do that, we will have to take, let's see, this goes down 3, goes down 3, and goes down 3. So we'll have to take, that's a 4. We'll have to take 3 away from this. So this is the y, remember? We're taking 3 away from it. And that's it. That's the answer to all of these. You can do lots of these transformations. We get used to, we've been taught the words for them. But a lot of students sort of glazed over the maths of them. But all these transformations and translations can all be made using maths, like this. So a minus to the x will do that. A multiply by the f will stretch it or squash it. Adding on to the x or taking away will move it left or right. Adding or taking away onto the whole function will move it up or down. This is one we use a lot, by the way. If there's anything you need to remember from here, adding or taking away from a function will move it up or down. That'll be probably the most important translation we learn. Okay, I hope that helped, but I do understand that it might not have. If you do have any follow-up questions, I will do my best to answer them. Put them in the comments below and I'll get back to you. Thanks for watching. Have a great day.